Good day, students. Today we proceed to video number 12, example 6. I read the question. A particle is acted upon by 4 coplanar forces. 5 Newton, 45 degrees, 8 Newton, 290 degrees, 290 degrees, 10 Newton, 150 degrees, and 4 Newton, 180 degrees. Find the magnitude and direction of the resultant force. That is the question. Here we have to draw the first diagram. We draw the first diagram of the question. We start by drawing the coordinate system. By drawing the coordinate system. The coordinate system. X. This is Y. Origin. Now the first force is 5 Newton at an angle of 45 degrees. Measure. Always we measure the angle from the vertical, from the north. So 45 degrees measured from the north will be somewhere here. So that is that force, which is 5 Newton. 5 Newton at an angle of 45 degrees measured from the north. Measured from the north. 45 degrees to the vertical. Then, since the whole angle here, this first quadrant is 90 degrees, the remaining angle to the horizontal will be 45 from 90, which is 45 degrees also. So, the first force of 5 Newton has been located. Then the second force, 8 Newton, 290 degrees. That 290 degrees also measured from the north clockwise. From here to here is 180. From here to here is 270. 270 from 290, that will be 20 degrees. So the remaining 20 degrees will be in this second quadrant. Then that will be the direction of the second force. Direction of the second force. 20 degrees. So that is the second force. Then the third force is 10 Newton, 150. 150 measured from the north. This is 90. 90 from 150, that is 60 degrees. So this force will be an angle of 60 degrees to the horizontal. Right. An angle of 60 degrees to the horizontal. This is 60 degrees to the horizontal. So that is that force. That force of 10 Newton. 10 Newton. Then the last force is 4 Newton, 180. Measured from the north, 180 would be here on this negative direction of y-axis. So that force of 4 Newton will be in this direction. 4 Newton. So the 4 forces have been located. Now the next thing now is to find the horizontal and the vertical components. Horizontal and vertical components. This is the force. Horizontal. horizontal component f of x, horizontal component f of x. Then we have the vertical component. The vertical component f sub y, the vertical component of the forces. So now the first force is 5 Newton. 5 Newton force. This 5 Newton force is at an angle of 45 degrees to the horizontal. So we resolve that 5 Newton, the horizontal component of this 5 Newton to this horizontal x-axis is going to be 5 cos 45. This is 5 cos 45 degrees. That will be 5 times 0 point. This will be 5 times 0 point 707.
3.5355.
3.5355. So then the vertical component will be, we resolve it vertically, that will be 5 and 45 degrees, which is also 5 times 0 point 7071, 3.5355. Then the second force is 10 Newton force, which is, if we resolve this 10 Newton force at an angle of 60 degrees to the horizontal, will be 10 cos, that is 10 Newton force. So the horizontal component of this 10 Newton force will be 10 cos 60 degrees, which is 10 times 0.5. That will be 5.0 Newton. This is Newton. Then the vertical component of this 10 Newton force, when we resolve it vertically, it will be negative because it is towards the negative direction of the y-axis. So the vertical component is going to be minus 10 sine 60 degrees. So that is minus 10. Can just give me the answer. That is
okay, minus 8.866.
Minus
8.866.
8.866. Okay.
Sine 60 is 0.8.
8.866.
866.
Okay. So that's what we have up. Okay.
8.66, sorry.
No,
8.66.
8.66.
Yes.
8.66.
Yes.
So that is the vertical component. Then I even brought my calculator.
Okay.
This is force. This is force. I think there's really no need of writing. This is force. Horizontal. Component f of x. Then vertical component, that is f of y. So now the third force The third force is 4 Newton. The angle between these 4 Newton force and the x angle is 90 degrees. So it's going to be, the force is 4, then the component is going to be 4 cos
Minus.
90 degrees.
Okay.
Resolve it this way to the plus.
Yes.
So that is going to be cos 90 is relative, 0 Newton. Then this will be minus 4 sine 90 degrees, you know?
Yes.
Which is minus 4 times 1, and that is minus 4 Newton. So this is 4 Newton, that is the third force. Then the last force is 20 Newton. 20 Newton. 4 Newton.
8 Newton.
It's 8 what?
Yes.
8 Newton. It's an angle of 30 degrees to the horizontal. So the last force is 8 Newton. Now the horizontal component of this 8 Newton force is toward the negative direction of the x-axis, so it's negative. That will be minus 8 cos 20 degrees. And the vertical component would be plus 8 sine 20 degrees.
Okay. 7.5175.
This one, what?
Yes.
Minus
5175.
7.5175. And this one is
8 sine 20. 2.7362.
2.7.
7362.
Okay. Now, the next thing now is to find the summation. So summation f of x. Now, starting from here, it's 3.5355. Now, only the summation, right? Now the summation of the horizontal component, which is summation of f of x, that will be 3.5355 plus 5 plus 0 minus 7.5175. What we have is, that will be equals to 1.018 Newton. That is summation f of x. Then for the vertical component, summation of the vertical component, that will be 3.5355 minus 8.66 minus 4 plus 2.7362. We have minus 4.3883. So that is what we have. Find the resultant. To find the resultant force, we now find the resultant force. Magnitude of the resultant force is equals to R, which is equal to the root of summation f of x squared plus summation f of y squared. So this means that the resultant force R is equal to the root of the magnitude of summation f of x is 1.018 square plus summation f of y square is minus 4.3883 all square. So the resultant is equal to the root of
1.0363
363 plus
4.38 19.2572.
72. Then, so that would be
plus 1.0 sorry 0363. Okay, 20.2935.
2935. Then the root of that
4.504 means 505.
4.505
505.
Newton. So that is the magnitude of the resultant. Then the next thing now is to calculate the direction. You can calculate this one.
Yes.
Calculate the direction. To find the vector diagram of summation f of x and summation f of y. Now, the formula of f of x is 1.018 and it is positive. So we draw that one. We draw that one a straight line in the direction of the positive x-axis. So in the direction of the positive x-axis, this is summation f summation f of x, which is equals to 1.018 Newton. Now, summation f of y is negative. Then from the head of this first vector, we draw the vector for summation f of y vertically downward in the negative direction of the y-axis because it is negative. So we draw that vector for summation f of y downward. It's moving downward, so that is summation f of y, which is equals to minus 4.3883 Newton. Now we have to close the polygon. I close the polygon by drawing the third side of that triangle. Now, which direction will be where will be the arrow? So now summation f of x is coming this way, summation f of y is this way. So the direction of this resultant force must oppose the direction of the other two forces. So it should be this way, this way. That is the resultant force. That is the resultant force. That is the resultant force. So let this angle be theta. Let the resultant force make an angle theta with the resultant. So, and then the direction now. To get the direction, I have to draw the north-south. So this is north. That is north. Then the direction now will be measured from the north, just like before, this way. That will be the direction of the resultant force. So, and how do you get that direction? Find this angle theta and add it to 90 degrees. That will give us the direction. So here, in that right angle triangle, tan theta is equals to summation f of y, that is opposite to our adjacent, over summation f of x. And that would be minus 4.3883 Newton over 1.018 Newton.
4 point.
Little personality.
4.31.
Tan theta is equals to
3107.
Minus 4.what?
3107.
So ignoring the negative sign in order to get the acute angle. Therefore, theta is equals to tan inverse of 4.3107.
76.94.
76.94. Okay. 94 degree, which is approximately equals to 77 degrees. You know?
Yes.
Therefore, direction of the resultant force now. The resultant force is equals to, from here to here is 90 plus this theta. That would be 90 degree plus theta degree. Plus theta degree.
89. Okay.
So, that is, therefore, direction of the resultant force is equals to 90 degree plus 77 degree, which is equals to
167.
167 degree. So, therefore, concluding, R now in polar coordinate form, R is equals to 4.5 Newton, 0.5 Newton, then 167 degree. So that is my answer.